So today we'll start the chapter that is amines. Okay, Fatima is here. Good. Did you try questions from carboxylic acid and that chapter, aldehyde ketones and carboxylic acid, guys? Amalya, Fatima, Sania, anyone?
No, sir.
No. What about you, Fatima? Yes. Do you have any doubts, Fatima?
The 12.818.
Okay. Wait a second.
In that, the second question is semi-carbazide something.
You have done no semi-carbazide. It is there in your notebook.
I couldn't find that.
If you go to reactions, the nucleophilic addition of carbonyl compounds, that we did.
Yeah, okay.
Got it?
Yes, sir.
Okay. Anything else?
No, sir.
Okay. So you did those reason one, like you have to give reasons for different things. You did those?
Yeah.
That was, huh? 12.20, I think. Assalamualaikum, Ahmed. How are you?
Assalamu alaikum, sir. So I'm good. How about you?
I'm good. Okay. So did you try questions from aldehyde ketones and carboxylic acid?
No, sir.
No. Okay. Okay, so you have the reasons for all of them, Fatima? The 3 questions in 12.18?
The 1 and 2 is fine. The second one was a bit confusing. I got it now.
You got it now. So what do you think? What is the reason? There are 2 NH2 groups in semi-carbazide. However, only one is involved in the formation of semi-carbozones. What do you think is the reason?
Resonance or something?
Yeah, correct. That is the resonance only because one of the NH2 groups, its lone pair will be in resonance. Is that? Yeah, so semi-carbazide. Yeah. So we have here so this NH2 group, it is in resonance. So this lone pair is not available for reaction, but this lone pair, this is available for reaction. That's the reason. Okay. Now moving on to amines. Okay. So let us start with some nomenclature, right? We will start with some nomenclature, then we will move on to the preparation of amines, and then we will be doing the physical and chemical properties. Okay. It is better if I give you questions from NCERT साथ साथ आपको वो भी हो जाएगा rather than giving my own questions. Okay, so first question is a bit easy one. You have to first of all classify the following amines as primary, secondary, or tertiary. So you understand primary, secondary, and tertiary, guys? Yes or no? Yes or no? You understand it, right?
Yes, sir.
हाँ. तो जल्दी बता दीजिए सर, है ना, all of you. Tell me. A1, 13.1. Primary, secondary, or tertiary?
Primary.
Primary. Very good. Sania, Fatima, Amalia, Ahmed, all of you understand this primary, right? Yes or no?
Yes, sir.
Yes, sir.
Okay. What about the next one?
Tertiary.
Tertiary. What about the next one?
Secondary. No, primary.
हाँ, जोर से बोलिए, जोर से.
Primary.
हाँ. And what about this fourth one?
Secondary.
Secondary.
Secondary. Yes, secondary, correct. Okay, now we will do some IUPAC nomenclature. Okay, so the first thing is that we have to make structures, है ना? So when you are going to make structure, you draw all the atoms which are not in bracket first. So you'll have carbon, which is bonded to hydrogen. Then you'll have further nitrogen, which is further bonded to hydrogen. So NH2. This carbon is now bonded to two different carbon atoms, CH3 and CH3. Yeah, try the name for this molecule. First of all, identify what is the functional group here. What is the functional group?
Amine.
Amine.
Yeah, amine. The unsaturation. Unsaturation means that does it have double bond, triple bond, or only single
Yes.
bonds?
Primary.
Single bond.
I mean single bond.
Single bonds, right? So it will be AN.
AN.
Then you have parent. So for parent, you have to identify the terminal carbons. Right? So how many terminal carbons you have? A and B. Only these are the two terminal carbons, right?
Yes, sir.
Yes, sir.
Right? So we don't have to do anything. This is going to be our parent chain because we don't have any other groups. So parent will be 1 to 3 carbons. So it will be prop. It will be prop. After that, the substituent. Is there any substituent here? No.
Sir.
And we have already done everything. We have named, see, this is the functional group. So we have already done naming the functional group. We have already taken care of the parent. So there is nothing left. So there is no substituent. So whatever is left after the identification of functional group, unsaturation and parent, is the substituent. So we have got the parent, we have got the functional group, we have also got the unsaturation. We now just need to number it. So if I want to number it, I can start from any of these terminals, A or B, because nitrogen is going to get second, number 1, 2, and 3. So this will be 2 amine. No, sorry, propane to amine. Propane to amine. Okay. Correct, guys? Yes or no? No problem, right?
No, sir.
No problem. What about the next one? So first of all, we will draw all the carbon atoms which are, so we have CH3. Now this is bonded to 3 times CH2, no, 2 times CH2, and then there is NH2. It is quite simple, I guess. 1, 2, 3 carbons. So this will be propane, 1 amine. Right? Yes or no?
Yes, sir.
Okay. And also there is a relationship between 1 and 2. So 1 and 2 are what kind of isomers? They are position isomers. 1 and 2 are, because everything is same, propane, amine, only the position of amine is different. So 1 and 2 are position isomers. Any problem here? Any problem till here, guys?
No, sir. No, sir.
No. Let us write the third one. That is more important. CH3NH. So there is CH3, which is bonded to nitrogen, which is bonded to hydrogen, and further bonded to CH. CH3. Okay. Now in this, you have to identify what is the functional group. Tell me. Amine. So whenever, if you have nitrogen which is singly bonded to carbon atoms, and you are having amine, then the functional group is going to be amine. Now tell me guys about unsaturation. Is there any double bond or triple bond?
No, sir.
Amalia, Fatima, is there any double or triple bond?
No.
So it will be AN. Now you have to identify the parent. So for parent, what you have to identify? You have to identify the terminal first. So the terminals are, this is the terminal carbon, A, B, and C. This is also the terminal carbon. Now, please remember that we have to only have carbon chain. Nitrogen should not come in between. And here we only have one carbon atom. So I am ignoring this terminal because it is not going to be, it's not going to be the parent chain. The parent chain will be this one, yes or no? Correct? So this is my parent chain. I've also identified the amine. And so parent is how much? Parent is 3 carbons. So this will be propane. This will be propane. Now we have one thing that is remaining to be included in the IUPAC nomenclature, and that will be the substituent. So what is the substituent? Methyl? Yes or no?
Yes, sir.
Methyl is a substituent. Now, it's very important to number the methyl. How should we represent this methyl, and how should we tell that it is attached to nitrogen? So simply what do? We add here N. So this is how we number the methyl. So methyl ka position kahan hai? Methyl is attached to nitrogen. So this is how we show it. So you will have N-methyl propane. Then this is 1, 2, 3. 2 amine. Got it, guys? Yes or no? Please tell me.
Yes, sir.
Yes. Fatima, Amalia, Sanya.
Yes, sir.
Okay. So I'm giving you a question.
Yes, sir.
Try this, CS3. Send the answer in chat. CH2, CH2, CS3. What will be the name of this compound? फातिमा, पेरेंट कितने कार्बन का है? Fatima, how much is the how many carbons are there in the parent? So you have what you have written in the parent. Please correct it, na? Okay, I've got 2 answers. Yeah, correct. Okay, I'm waiting for answers from Amalia, Sanya, and Abir.
Sir, I sent the answer.
Amalia, you have sent the answer? किसको भेज दिया आपने? To whom did you send it? Amalia? Yes, Tanya, correct. Yes, Sabir, correct. There is just one mistake in your name, Abir. It will be propane में E नहीं होगा. You will not have any E in propane. It will be PROPAN. Now I have got your answer. Okay, yeah, correct.
So can you explain this one? The numbering, we will start from right or left. This propane.
Okay, sure. So we have functional group, that is amine.
Mean.
Then we have the unsaturation, that is going to be AN. The parent, it is going to be prop,
Prop.
right? And the substituent is methyl.
Methyl.
Rather, I can write N-methyl because it is attached to nitrogen, N-methyl. Now, so we have this parent and we have to number it. So this parent has two terminals. It is A and it is B. This is also a terminal carbon. Why? Because there is no carbon after that. There is no carbon directly attached to this carbon, right? So B is also a terminal carbon. Now we can start. There are only two ways of numbering. I can either do a numbering like this: 1, 2, and 3, or I can do 1, 2, and 3. So there is a rule which is lowest locant rule, which says that the sum of all the positions that you have mentioned in the nomenclature, it should be lowest. It should be lowest. So I will be choosing the first one, right? 1, 2, 3, the green one. You got it, Abir?
Yes, sir.
So this will be N-methyl. N-methyl propanamine. Okay. So what else do we have here? Let us do.
So is it necessary to amine?
Sorry.
Is it necessary to write one amine? N-methyl propane, one amine.
No. It is not necessary to write for one methyl. So this can be also written as N-methyl. Propane, one amine. It can be also written as N-methyl. N-methyl. One propanamine. But I will always prefer this one, okay, that you have written. It is just a like, what do you prefer to write? Otherwise, all three names are okay. All three names are fine. Okay. So let us try this MBrC6H4NH2. MBrC6H4NH2. Okay. So our structure, first of all, we have to draw the structure. So C6H4, it will be a benzene ring. It has NH2 group attached to it, and it also has a Br group in the meta position. Yes or no? Correct, guys?
Yes.
Okay. So there are two ways of naming it, and both of that will be correct. So I will give you the first of all the IUPAC systematic nomenclature for this molecule. So when you have a benzene, whenever you have benzene, so we have these things, right? Substituent, then we have the parent, then we have the unsaturation, and then we have the functional group. So in terms, whenever you get a benzene, so this puff, right? Puff, that is parent, unsaturation, and functional group, this PUF. For all these three, we have only one word, that is benzene. Okay, and the rest of them are substituent. So I have two substituent here, NH2 and Br. So NH2, the name for NH2 as a substituent, it is amino. And for Br, it is bromo. So I've got the substituent. Now I have to number them. Because I have also to tell in the name where are they placed relative to each other. So I will start with, if I see amino and bromo, so A is alphabetically before. So I will give this 1, the amino carbon, the carbon which has amino group 1, 2, and 3. And I will name this as 1 amino, 3 bromo, 3 bromo, benzene. 3-bromo-benzene. Okay, so this is one name. This is one name. Next, the next way of naming, and which is also the, I would say that is the preferred IUPAC naming. Preferred IUPAC naming that is mostly used whenever you look at these type of molecule. It uses the benzene ring that is attached to NH2 as the base, as a basis for the naming. So this whole group, it is known as, do you know its name, what it is called as? Benzene ring attached to NH2. Benzene ring attached to NH2. This is aniline. The shaded part is aniline. And we have Br at the meta position. So we can write M bromo aniline. Right, guys? Yes or no?
Yes, sir.
Yes, sir.
N bromo aniline. Okay. So write this down. Write this down. And we can also write 3-bromo aniline. So in aniline, the first carbon is the one which is having NH2 group.
Yes, sir. Done.
Then all of you, yes or no? What about others?
Yes,
Yes, sir.
sir.
Okay. So let us now write the, now let us write the preparation. Okay. So write the preparation of amines. Preparation of amines. So the first method of preparation of amines, please write this with me, from alkyl halide. Number one is alkyl halides. Now alkyl halide, in this, the first reaction that we will see is the ammonolysis of alkyl halide. Alkyl halide. So hydrolysis, it means reaction with H2. Ammonolysis means reaction with ammonia. Reaction with ammonia. So you have RX. We have seen this reaction when we were learning about the, the reactions of alkyl halide. In that we have seen. Please write when aqueous or alcoholic solution of, when aqueous or alcoholic solution of ammonia is heated with alkyl halides, at around 100 degrees Celsius, that is 373 Kelvin, right? 373 Kelvin. In a sealed tube, then all three types of amines are obtained. Okay, so we will see what are those three types of amines that we are talking about. So you have a reaction like this, that there is Rx, it is treated with NH3 with some heat. So first of all, what is going to happen in this case, that the nitrogen's lone pair, it is going to attack on the Rx bond, and this X bond will leave. Simple substitution, nucleophilic substitution reaction, and you will get R, which is bonded to NH3. Now, since nitrogen is bonded to 4 different atoms, it will get a positive sign. And this X negative which left, it will also have a negative sign. So now you are making a 1 degree amine salt. 1 degree amine salt. Okay, 1 degree amine salt. Then what happens? We react the same 1 degree amine, that is 1 degree amine salt, RNH3, which is having a positive charge, and X negative, plus there will be some other molecules of NH3 there. There will be some other molecules of NH3 there. So this NH3 now, this NH3, it has a lone pair here. It has a lone pair, and then it attacks on this R, and this whole thing leaves. So you get NH4, NH4 positive, NH4 positive, and there is a X negative, plus you get RNH2. So it happens something like this. Let me just expand it. You have R nitrogen. So it has hydrogen, and there are 2 other hydrogens like this, and this also have a positive charge. Now this nitrogen which has a positive charge, which is an electronegative element. Now this nitrogen, which is already an electronegative element, which is having a positive charge, it makes it more and more electronegative. So nitrogen is pulling all the electrons from the hydrogen, and hence this nitrogen, it attacks on one of these hydrogen. It attacks on one of these hydrogen. Now this hydrogen bond, it gives out the electron to nitrogen. So we get RNH2 with a lone pair of electrons, and this NH3, it becomes NH4 positive, and the X negative just shift towards the NH4 positive rather than RNH2. So this is how the reaction happens. So first of all, we make 1 degree amine salt, and then another reaction happens, and what do we get? And we get a simple amine here, and we get a simple amine here. Now next is, if you have the 1 degree amine salt, another way to get the primary amine from the salt is you treat the RNH3 positive and X negative with NaOH. So basically we are treating this with base. Here also it was a base, here also it is a base. Now same thing, NaOH is also doing the same thing. The OH negative from NaOH, it is going to abstract the hydrogen from NH3, and it is going to make water, plus then we will be having Na positive, which will attack on the X negative. So Na positive and X negative, they will make NaX, right? It will make NaX, plus we will be remaining with RNH2. Okay, we'll be remaining with RNH2. Okay, let me know if this is fine. Correct? Yes or no?
Yes.
Any problem till here? No, no. So you will first of all make 1 degree amine salt, then you will treat this with base, and after treating with base, you will get a 1 degree amine. Here also 1 degree amine. Now let us see what happens if I do the reaction and just keep on doing this reaction. I have RNH2. I have RNH2, and I react this with, wait a second. Let me start with NH3. So I have NH3. I react this with alkyl halide at 373 Kelvin. So what I will be getting? I will be getting RNH2. Right? We got RNH2. Then I further reacted this with RX, again at 373 Kelvin. Now again, what is going to happen? This nitrogen, which is 1 degree nitrogen, sorry, 1 degree amine, and the lone pair is going to attack on the Rx, and this X is going to move, and then again you will get R. Here you will be getting N, H, and there will be another R group attached here. You can do one more reaction. You can again react this with Rx, with at 373 Kelvin. Then you are going to get R, N, R, and R. So first of all, you will get 1 degree amine. On further reaction with alkyl halide, you will get 2 degree amine. On further reaction with alkyl halide, you are going to get 3 degree amine, tertiary amine. And you can react this one more time because we still have the lone pair. So when I react this again with Rx, at 373 Kelvin, I am going to get R4, which is completely attached to nitrogen, which will get a positive, and you will get a X negative. Now this is quaternary ammonium salt. Quaternary ammonium salt. Quaternary ammonium salt. Now obviously this is not going, so whenever we are doing the reaction of ammonolysis of alkyl halide, we will be getting some mixture of product. There will be some 1 degree amines, some 2 degree amine, and there will be also some 3 degree and 4 degree amines. Okay. So this is a simple nucleophilic substitution reaction that we have already seen, right? Now we have to compare the reactivity of different halogens, reactivity of different types of halide, the rate of reaction for different types of, so reactivity of halides, reactivity of halides. So obviously main thing is that in halide, what is happening? This bond is going to break. Rx bond is going to break. So if the Rx bond is weaker, so reactivity or the rate will be directly proportional, inversely proportional to the Rx bond strength. Right. So if the bond is stronger, that means it will take more long and the reaction will be slower. And if the bond is very weak, the reaction will happen quite fastly. The reaction is going to have quite fastly. So we'll have the order such as Ri will be most reactive, followed by Rbr, followed by Rcl. And Rf, it does not give ammonolysis reaction very easily because Rf bond, these are strong because fluorine is also in the second period, carbon is also in the second period, and the overlapping between those two orbitals are going to be very effective between fluorine and carbon. That is why ammonia is not able to replace fluorine very easily. Fluorine is always a bad leaving group. Okay. So what if we have benzyl halides? What if we have benzyl halide? So if I have benzyl halide, something like this. Please remember benzyl halide is this benzyl halide? Is this benzyl halide? Okay, tell me, is this? Okay, this is not benzyl halide. Okay, please remember, this is not benzyl, this is phenyl. This is the phenyl group. This is not the benzyl group. What is benzyl halide? Benzyl halide, if you have CH2 and that is attached to CH2 and that is attached to an X. If I treat this with ammonia with some heat, then that X will be replaced by NH2. CH2, NH2. So this is benzyl halide. And this is benzyl amine. This is benzyl amine. Okay. Now the limitations. Acha, one thing I just wanted to say that I will give you this PDF. Okay, so don't write right now. I will ask you some questions, then you note them down in the notebook and try to answer them. Otherwise, while explaining, please don't write it. Okay. Next is the limitations for this method. Limitations. So the first limitation is that obviously it is going to give you a mixture of different type of amines, 1 degree, 2 degree, and 3 degree amine. So this produces a mixture of different types of amines which are difficult to separate. Okay. Second thing is if I want if I want to have only 1 degree amine, then I will have to use a excess of ammonia, because see, if I have Rx and if I have too much ammonia, like NH3 is 5 times of the initial amount of Rx, then what is going to happen? The collision of Rx is probably going to happen with NH3 only. It's probably going to happen with NH3 only rather than any 1 degree or 2 degree amine. So next is that we have to use a large amount of ammonia to prepare large amount of ammonia is consumed for preparation of 1 degree amine. Okay, for preparation of 1 degree amine. And if you want to make a quaternary salt, then we use large amount of alkyl halide is used, consumed for preparation of quaternary ammonium salt. The next limitation is that we cannot prepare any aryl halide. We cannot use any aryl halide, or we cannot use this method of preparation for the formation of aniline. This method is not suitable for preparation of aniline. Why is it not suitable method? Because if I take a benzene ring which has a halogen directly attached to it, so this bond is going to be a partial double bond due to the lone pair and the resonance from halogen atom and the benzene ring. So this is going to be a partial double bond, plus we have NH3. So NH3 is going to be, NH3 has to attack on this carbon atom, but it can't attack on carbon atom. Why? Because this benzene is also electron rich, so there will be some repulsion, and this carbon is also not very much delta positive because it is sp hybridized and there is a double bond, and that is why this CX bond cannot break. So all of the reasons are the same reason that we studied about the why alkyl halide does not give nucleophilic. So sorry, why aryl halide they do not give nucleophilic substitution. So the reaction is not going to happen. Okay, this reaction is not going to happen here. So this is the first method of preparation. Let us write the second method of preparation, that is from nitrites. You can also write nitrites, and similarly you can also use nitro compounds also. Both of them will be reduced. First of all, let us write nitrite. A reduction of nitrites. Reduction of nitrites, and I also isonitriles and also isonitriles. Okay. So first question is then, what are the reagents that we have to use? So we will be obviously using reducing agent. We will be using reducing agent. So please write reducing agents such as reducing agents. So the reducing agents that are used H2 in the presence of nickel. You can also use H2 in the presence of platinum. You can also use reducing agents such as LiAlH4. You can use sodium Hg. Okay, so these are the important ones, sodium Hg, or you can also use some alcohols here, or you can use some alcohols, importantly ethyl alcohol, C2H5OH. Okay, so if I have CH3CN, a simple nitrite, then in the presence of LiAlH4 or any of the reducing agent, what is going to happen? This carbon, okay, wait a second. CH3C triple bond N. So both of these pi bond are going to break, and 2 hydrogens on the carbon and 2 hydrogens on the nitrogen, they are going to attach. So we need 4 hydrogens are consumed for the conversion of nitrile to amine. We'll have CH3 bonded to carbon, CH2 single bond NH2. A simple reaction, okay, a simple reaction. And this can be also done if you have benzonitrile. If you have benzonitrile, which means it's a benzene group with a carbon attached to it with a triple bond nitrogen. So supposedly you are using LiAlH4, then you will have the benzene ring, CH2, NH2. Okay, as simple as that. So I'm writing a few reactions here. You just write the product for this. CH3, CH2, C triple bond N. Let us have H2 in the presence of nickel. C triple bond N. H2 in the presence of platinum. And write the product for the following: CH2 NH2, CH2 NH2, CH2 NH2, nothing else. Easy.
Yes, sir.
Done all of you, yes or no?
Yes, sir.
You're done now. Okay. What about others? Fatima, Sania, Amalya.
Done, sir.
Yes, sir.
So simply you will have CH3, CH2, CH2, NH2, CH2, NH2, CH2, NH2. Okay. Now the next reaction is with if I have alkyl isocyanate. So here I am writing with isocyanide, or we call this as also isonitrite. Same thing. So in isonitrite, the difference is here we have Cn and there we have Nc. So if I have CH3 that is bonded to a nitrogen which is triply bonded to carbon atom. So this is the bonding in isocyanate. So this is what? This is methyl isocyanide. This is methyl iso.
N is having 4 bonds.
Yeah. Methyl isocyanide. So if I attach here carbon atoms, then what is going to happen? If I attach here hydrogen atoms, for example, H2Ni, then you will get CH3, NH2 and CH2. NH2 and sorry, CH3. Right? Yes or no? Okay, same type of reaction, same type of reaction. So if I have also, let us say, is bonded to nitrogen, which is triply bonded to carbon atom, then you will have NH2. Sorry, here there will be NH, not NH2, and CH3, because nitrogen will have 3 and it will have 4. So here will be having NH, CH3. You see, carbon also here is having 3 bonds. Yes or no, Abir?
Yes, sir.
Ahmed, carbon is also having 3 bonds. Hai na? That is why carbon will be negative, this will be positive, and that is why it is completely neutral. Okay.
Yes, sir.
So write a reaction for this. The nitrogen triply bonded to carbon atom. So H2 in the presence of, let us say, Pt. So write the product for this one. Let me know if you write the product.
Yes, sir. Done.
Done. Okay. So next is your reduction of nitro. Reduction of nitro groups. Acha, you got the. I don't think I have write the product. It is easy only. You must have got it right. NHCH3. Right, NHCH3. Next is reduction of nitro groups. Reduction of nitro groups. So in nitro groups, what do we have? RNO2. RNO2. So again, we can be using reducing agents. Reducing agents. So reducing agent again. Yeah, I will send this PDF. I will send this PDF. Reducing agent, H2 in the presence of nickel, or you will have H2 in the presence of PD, or you can also have H2 in the presence of PT. Now, what else we can use? We can also use, there is another class of reducing agent, which is SN in the presence of HCl, or iron in the presence of HCl. Okay, so these are the two classes. Next is, you can use LiAlH4. LiAlH4 also. Achha. So these things, these are known as active metals, reduction by active metals. The first one is known as catalytic reduction. Catalytic reduction. Okay. In all of them, what are you going to get? You are going to get, you can use RNO2. If you use any reducing agent, you will get RNH2. Simple reduction, RNH2. Even if you have nitrobenzene type of thing, you use any reducing agent, you will get RNH2. Any problem till here, guys? Tell me.
No, sir.
Okay, so write some questions and you will write the products. CS3, NO2 in the presence of, let us say, Fe in the presence of HCl. हाँ बताइए.
So for aryl NO2.
हाँ, sorry.
Aryl, right?
Thank you. हाँ, got it. Yeah. Done, yes or no?
Yes, sir.
Yes, sir.
Done, na? So this will be CS3NH2. H2. Okay. Next is reduction of amides. Reduction of amides. Okay. What number is this? This was second, third, and this will be fourth. So just write one note. So when we use the active metal case, when we use Fe in the presence of HCl, then we form FeCl2 and then it gets hydrolyzed and it releases hydrochloric acid. So that is why a very little amount of hydrochloric acid is used as starting material, because it also get produced in the product. So just write a point here that Fe, presence of HCl, is preferred as it produces FeCl2 and gets hydrolyzed to form HCl. So very less amount of HCl is needed initially. Initially. Okay, next is reaction with amide, of preparation with amides. Reduction of amides. Reduction of amide. So again, reduction of amide, it can be done by LiAlH4 or sodium in the presence of ethanol. Sodium in the presence of ethanol. We have R with C double bond O, and we have NH2. We have NH2. So we just use LiAlH4, the first LiAlH4. Then we do work up with water and we get R CH2NH2. R CH2NH2. So if we have something like this, CH3, C double bond O, there's nitrogen attached here, and this nitrogen is further attached to CH3. Then if I use the same reagents, LiAlH4 in the second case, second step, LiAlH4 in the first step, and the second step, just add water. So in this case, what is going to happen? This oxygen is going to leave. This carbon is going to get 2 hydrogens, and this nitrogen is also going to get how many hydrogens it's going to get? It's going to get no hydrogens. You will just get CH3, CH2. You'll get NH, CH3, NH, CH3. Okay. So it depends what type of amide you are using. So if you use 1 degree amide, then you are going to get 1 degree amine. If you use 2 degree amide, then what are you going to get? You are going to get 2 degree amine. Now, if we just go crazy and we use 3 degree amine, CH3, C double bond O, nitrogen which is bonded to CH3, and one more CH3 in the presence of LiAlH4 and water, we will get CH3, CH2, nitrogen, CH3 and CH3. Okay, so here we have 3 degree amine, 3 degree amide, which forms 3 degree amine. Okay, any problem, guys? Yes or no? Please tell me. Any problem with these 3 preparations?
No, sir.
No. Okay. So just write some questions and then you can form the products. Okay. To make products for these 2.
And so it should be NH, right?
Sorry,
Second
NH. Yeah, correct.
sir.
Then for the A1, yes or no?
Yes, sir.
What about B1, guys? Yes, Amalia, Fatima, Sania,
Yes,
Abir.
sir.
Done. And so see, you have to keep your focus where the change is happening. If you look at the change is happening only at this carbon atom. Only at this carbon atom, everything else is same. So you don't lose your focus. You will be just focusing on this carbon atom and you will be bringing out the change here only. Okay. So in this case, you will have, so you will write all the things as it is. This will get CH2, have NH, and cyclopentene. Here also, the benzene ring will be as it is, CH2, NH2. Okay, CH2, NH2. Done, all of you? Yes or no? Done.
Yes, sir.
Yes, sir.
Next is Hoffman bromamide degradation. This is important because it is a name reaction. Okay, this is going to be important. Hoffman bromamide degradation. Bromamide degradation. So in this, first of all, we'll write the statement. Primary amines can be prepared by treatment of amides with Br2 and KOH or NaOH. KOH or NaOH. One important point is that the amine formed by this reaction has one carbon less than the original amide. And that is why this is known as, hence it is known as degradation. We are going lowering, we are lowering the number of carbon atoms, that is why it is degradation. So in the reaction, you will have R, C double bond O, NH2 plus Br2 in the presence of KOH or NaOH. Br2 and KOH or NaOH, and you are going to get 1 degree amine. So what is going to happen? R NH2 directly, and this CO will just leave that CO out. So you will get R NH2 plus the byproducts are K2CO3, KBr, and water. So the important product for us is RNH2. So if I have CH3, C double bond O, NH2, and in this we are using Br2 plus NaOH or KOH, then what is going to happen? This, you just have to remove this carbon atom, just remove this CO bond, carbonyl carbon, and then attach the CH3 NH2. CH3 NH2. CH3 NH2. Any problem, guys? Yes or no? Please tell me. Now, this is going to be a very good method for the preparation of anilines. Why? Because we'll have benzene, which is bonded to C double bond O, NH2. So we have now got a benzamide, and if I treat this with the Hoffman bromamide degradation reagent, then what is going to happen? This CO will be, the carbonyl carbon will be left out, and you will get aniline. The carbon directly bonded to NH2. This is your aniline. Okay. So understand what you have to do? Yes or no? Please tell me.
Yes, sir.
All of you got this? Yes or no?
Yes, sir.
Okay. So wait a second. Let me just see. Okay, fine. So you don't have to look at the mechanism here. Now this is optimal bromide degradation. Then we have the last one, that is Gabriel Thalamide synthesis. Gabriel Thalamide synthesis. Gabriel Thalamide synthesis. Okay. So first thing, you have to remember one molecule, that is a benzene ring. Here you have C double bond O, and here C double bond OH, C double bond O, OH. Okay, so this is known as phthalic acid. Okay, so can you remember this molecule? Yes or no? Please tell me. Phthalic acid. हाँ guys, ये याद रहेगा phthalic acid. You have in benzene ring, if two adjacent carbon atoms, they have carboxylic acid attached to it, it is known as phthalic acid. Okay, it is known as phthalic acid. Now thalamide, it is going to be a derivative of phthalic acid, in which you have C double bond O, C double bond O. This is going to be same as it is, and rather than two different OH, you will have one NH attached to those two carbonyl carbons. You will have one NH that is attached to those two carbonyl carbon. Okay, so you have a molecule like this, nitrogen, and this nitrogen also has hydrogens because it is going to have three carbon atoms. Sorry, three bonds. Nitrogen should have three bonds. This is thalamide. Thalamide. Okay. So when you have thalamide and you react this with KOH, you react this with KOH, then what is going to happen? You will replace this hydrogen with the K, and water will be left out, right? So you will have the same molecule. Nitrogen, doubly bonded with oxygen, doubly bonded with oxygen, and here you have negative, and K will be positive, and plus you will form water molecule. Plus you will form water molecule. Now this is what? This is potassium thalamide. Potassium, such as potassium chloride. So here this is potassium thalamide. Potassium chloride may we have K plus Cl negative. In potassium thalamide, we will have the potassium with positive sign and the thalamide where N is having negative. Thalamide. Next, what we do? Next, we react this with any alkyl halide. Next, we react this with any alkyl halide. This is very interesting reaction. We use such a large molecule to prepare such a small molecule. So what do we do? Negative, double bond O, double bond O. Okay, and there you have K positive somewhere, right? You have K positive here, and you treat this with, let us say, any alkyl halide RX. Any alkyl halide RX. Now, what is going to happen in this case? In this case, this nitrogen, which is having a negative charge, that means it is obviously having lone pairs. This lone pair, this is going to attack on the R group, right? This X is going to leave, nucleophilic substitution reaction, and you will get the benzene ring, nitrogen, double bond O, and this nitrogen is attached to R group. That is this R group is what? This R group is from the alkyl halide that we took. The alkyl halide that we took. After that, we react this with water hydrolysis, acidic hydrolysis or basic hydrolysis. Any type of hydrolysis you do, H2O. in OH negative or you do this in H positive, you're going to get, depending on the condition, depending on the condition, you will get C double bond O, O negative, O negative. So if you're using basic condition, then you are going to get COO negative, and if you use acidic condition, then you are going to get COOH, because if you have base, that will abstract the proton. So let me say that we are going to use acidic condition, and here we have the R NH2. Here you will get RNH2. Okay. So please remember, in this case also, what is going to happen? You have Rx and NH2. Now, why is this method used instead of the other method? Because as you can see, there is no more chance of any reaction of this NH2. Okay, RNH2. You will only have one type of reaction from R and X, and you will not be getting any mixture of product. You will only get one product, that is RNH2. And if you get phthalic acid and RNH2, you can see the size difference. And if there is a large size difference, there will be difference at the boiling point. And if there is a difference at the boiling point, then we can use the distillation method to separate this. Okay, we can use distillation method to separate this. Now, one more thing is that this phthalic acid that we have produced, it can be converted furthermore to thalamide again, and this reaction can proceed further. So whatever product you are going to get, in this case, it is all useful. The phthalic acid is also useful. The amine is also useful for the reaction. Amine is the product that we want to get, and phthalic acid can be again converted to thalamide in order to produce again 1 degree amines. Okay, again 1 degree amine. So please see this reaction. It has a very huge molecule, that is thalamide, but thalamide it has nothing to do with the product. Our alkyl halide that we are using in the intermediate step is the one which has the R group in the NH2, R group and in the NH2. Okay. So if I give you some reaction like this. So in the first step, we are going to do AOH or NaOH. Second step, we are going to add, let us say, CH3, CH2Br. And in the third step, I'm going to give you H2 in the presence of H+. So you don't have to do anything. You identify what, can all of you identify what is the alkyl halide given in the reaction? What is the alkyl halide, guys?
Thalamide,
What is the alkyl halide?
alkyl halide, bromoethane.
Yeah, it is bromoethane.
Ethane.
Bromoethane, hai na? 2 carbons. So you will just make CH3, CH2 rather than Br, you will just write NH2. Okay, this is going to be your product plus the phthalic acid. Now, it doesn't matter what alkyl halide you are using. Even if I give you S3Br, third step H2 in the presence of H+. Then also you are going to get CH3 NH2 plus phthalic acid. So phthalic acid is going to be a constant thing that you get in all of the products. OH double bond O, OH double bond O. Okay. So understood, you all of you understood now how we have to make this? Yes or no?
Yes. Yes.
Okay. So I will give you questions. Let us do 2-3 questions. Let us do, hai na? How will you? bring about following conversions. Okay, so basically I will start with one molecule, that is CH3, CH2, Cl. Okay. Now from this molecule, I have to make two different molecules. I have to also make from this CH3, CH2, CH2NH2. From this, I have to make CH3, CH2NH2. Okay, so can you see what is the difference between A and B? This is the A conversion we have to do, and this is the B conversion that we have to do from the same compound, that is chloroethane. So please look at the difference in A and chloroethane and B and chloroethane. Is there any difference? What is the difference, and how are we going to bring about the conversion that we have here? Please speak loudly.
Propanamine and ethylamine.
So yeah, A and B में difference तो ठीक है, but A and B का लेना देना नहीं है, because I have to form A from this molecule, that is CH3 CH2Cl, है ना? CH3 CH2Cl.
Yes, sir.
So what is here? We have bromoethane, and in A we have what?
Propane.
Here we have 2 carbons, here we have 3 carbons. So I told you there is one very elegant method of introducing one more carbon atom, adding one more carbon atom. Do you guys remember it? Yes or no?
CN, reaction with CN.
CN nahi, KCN. Reaction with
Yes.
KCN. So for the preparation of A, what we will do, first of all, CH3, CH2, Cl. We will react this with KCN. Right? So you will introduce one more carbon atom, CH3, CH2, Cn. Now you tell me you have nitrile, and how can I produce amine from nitrile? Is there any way of preparation of amines from nitrile?
Yes, sir. Yes, sir.
Yes, no, we did today.
Yes,
We did
sir.
today.
Reaction with H2 and PT.
H2 in the presence of palladium,
Yes, sir.
nickel, PT, है ना? So H2, PT, you will get CH3, CH2, CH2, NH2. Okay, and for the B, we have CH3, CH2, Cl, right? You have CH3, CH2, Cl. So you'll do the Gabriel Thalamide synthesis, right? Gabriel synthesis. That is, we will take a Thalamide. In the presence of KOH, and then we will treat this with CH3, CH2, Cl, and then H2 in the presence of H plus, you will get CH3, CH2, NH2. है ना? Please remember, we will not do directly ammonolysis, because ammonolysis is going to give you mixture of product. It is going to give you mixture of product. Next important one is, if you have CH3, CH2, C double bond O and NH2. So this is one, this is amide, which has 3 carbon atoms. So from this amide, I can go and form CH3, CH2, CH2, NH2. That is amines with 3 carbon by using LiAlH4. But if I do Hoffman bromamide degradation, right? If I do Hoffman bromamide degradation, that means Br2 in the presence of NaOH, then I will be getting the CO will be gone away, and you will be getting CH3, CH2, NH2. Okay, so these are 2 very important methods of preparation of making the number of carbon atoms. Here it is 1 carbon less, and here it is Here it is one carbon, sorry, here all the carbon numbers are same, and here we have one carbon less. So please remember these two methods, that is Hofmann bromamide degradation. It will give you an amine from amide with one carbon number less, okay, with one carbon less than the original amide. Okay, so this is all about the preparation, and let me give you some question. Okay, so this will be in your PDF only. This is going to be homework. So please, you have to write your notes down. You just have